Imagine being able to connect to high-speed internet from the middle of the ocean, from the peak of a remote mountain, or even deep in the desert, with performance close to fiber broadband. This is not science fiction. This is Starlink, SpaceX's ambitious satellite internet project. And today we're going to explore exactly how it works. Traditional satellite internet relies on just a few massive satellites parked 36,000 kilometers above Earth. The result? Slow speeds and huge delays. Starlink flips this model completely. Instead of a few satellites far away, it uses thousands of small satellites in low Earth orbit, just 550 kilometers above us. This means faster speeds, lower latency, and coverage that can reach almost anywhere on the planet. The Starlink network is built on three core parts. First, ground stations. These are the connection points to the traditional internet. Over 140 are already in place worldwide, sending and receiving data to satellites passing overhead. Second, the satellite constellation. As of 2025, there are over 7,600 Starlink satellites in orbit, making up nearly 65% of all active satellites in space. SpaceX plans to grow this to 12,000, and possibly even 34,000 in the future. And third, the user terminal, famously nicknamed Dishy McFlatface. This compact, high-tech dish connects directly to the satellites and brings Starlink signal into your home. Each Starlink satellite is a compact powerhouse of technology. They orbit Earth every 90 minutes at speeds of 27,000 kilometers per hour. They last between 5 to 7 years before safely deorbiting. Inside, they carry optical space lasers, up to 200 gigabits per second, allowing satellites to communicate directly with each other in space. Advanced antennas, for both user connections and ground station links. Argon ion thrusters, the first ever flown, to change orbit, avoid collisions, and deorbit at end of life. Star trackers and reaction wheels, to keep perfect alignment. Dual solar arrays and high-capacity batteries for power. Your Starlink dish is one of the most advanced consumer antennas ever made. Inside, it has 1,280 small antennas, each a hexagonal patch that can send and receive high-frequency signals at 12 gigahertz. By adjusting the timing and power to each antenna electronically, the dish can steer its signal beam without moving mechanically. That means it can track satellites moving across the sky at incredible speed, and instantly switch to a new one when the old one disappears over the horizon. Here's the journey your data takes with Starlink. Your device sends a request to your Starlink dish. The dish beams it to the nearest satellite overhead. The satellite either sends it directly to a nearby ground station, or passes it along to other satellites using its laser links. A ground station connects to the global internet and fetches your data. The information travels back the same way, through space, right into your home. This shorter distance compared to traditional satellites means latency as low as 25 milliseconds, similar to fiber internet. A geostationary satellite sits 60 times farther away than Starlink's LEO satellites. That's why old satellite internet had over 600 milliseconds of delay, making gaming, video calls, and real-time work frustrating. Starlink changes that. Its proximity means smooth video calls, real-time collaboration, and even competitive online gaming. Running thousands of fast-moving satellites isn't easy. SpaceX must constantly prevent collisions using autonomous avoidance systems, seamlessly hand off connections between satellites every few minutes, manage complex routing through a space-based laser network, coordinate radio frequencies worldwide to avoid interference. Starlink is still evolving. Upcoming developments include more satellites with laser links for fewer ground stations, direct-to-cell service letting phones connect straight to satellites, higher capacity with the V2 and V2 mini satellites, and in the far future, adapting the system for a Mars internet network. Starlink is more than just internet from space. It's one of the most ambitious engineering projects ever attempted. From argon thrusters to phased array antennas, from a global laser mesh in space to instant handovers between satellites, it's redefining what's possible for global connectivity. For people in remote villages, ships at sea, scientists in polar stations, and one day, astronauts on Mars, Starlink could be the link that connects them all. Exploring the tech that shapes our future.